Good afternoon, students. Today we'll discuss about the quantum numbers. What are the quantum numbers? What we have to discuss in this? Let you know that here. So we have to study about the Bohr's correspondence principle as well as the Pauli's exclusion principle. So in microwave or far infrared region, near IR region, infrared region, and also visible or near ultraviolet region. So these are to be observed. So here, how the splitting of electrons in an atom, which should takes place, which was proposed, first proposed by the Gaudsmit and Uhlenbeck, okay, in 1925, and also they have been explained the double line structure of the alkaline metals. So not in a single line, it is to be getting here. There should be getting a double line structure. So according to the Bohr here, the each atom of the element of atomic number Z, which is built from the atom of the element of the atomic number, which is by adding one more to the electron, later on here atom is going to be keeping, so that atom is to be form in neutral here, so that here what is the correspondence principle? So Bohr he proposed the hydrogen atom, which is combining both classical as well as the quantum quantum uh, concepts here. So here when the quantum number so in this case, here According to the correspondence principle here, you need to know about that uh, the prediction of the quantum theory for the behavior of the an atomic system must be corresponding to the prediction of the classical theory. And also, when the quantum theory is taken to the classical limit. So, what is the classical limit for the quantum theory? Which is to be situation of the transition between nearby states having very large principal quantum. Okay, and it is to be shows that the quantum and classical theories which can give the identical prediction for the radiated frequency in this limit. So Bohr he has been used that to deduce what selection rules apply to the transition between particular state of the art. So here classical electromagnetic theory, which can say that the frequency emitted radiation, which is equal to the frequency of revolution, and also limit of transition between nearby states, which is having the classical theory and Bohr's theory yields the same results. So which is to be satisfying the correspondence. So let you know about the what are the quantum numbers here. So here Bohr, according to the Bohr's here, which have been explained the hydrogen spectra with the circular orbits. Later on, Sommerfeld entered, and he has been assuming that not a circular elliptical orbits are there, and because of these orbits played such an important role later, which can give the development of the atomic structure, and also here the result of Sommerfeld theory, which shows that the electron in any one of the allowed level for the hydrogen atom may move in any one of the number of orbits. Let us consider that n equals to 1, 2, 3, etc. These are the n possible orbits. So you can see the figure here. Which one is the circular? First is the circular. Later on, which is to be showing that here L equals to orbital quantum number, principal quantum number is there, and what is 2s and what is 2p, which is equals to L equals to 1 and n equals to 2. Similarly, ground state, which is to be showing that dotted line, L equals to 0 and L equals n equals to 2 is 2s. Next, n30 means 3s, L1 means 3p, L2 means a beautiful diagram to know that how the electron orbits for the hydrogen atom according to Bohr-Sommerfeld theory. So like that SPDF. So what is the total orbital angular momentum? PL equals to LH by 2 pi or else H cross. Okay. So this is the hydrogen spectra which is closely packed here. How the spectral lines, the entire is 1.59 Armstrongs wavelength, which is related to here the 6564 Armstrongs. So that you can have for yellow color sodium light 5890 as well as the 5896. So the average which is to be considering 5893 Armstrong for yellow color. What is the difference is there? 6 Armstrongs only. These two spectral lines. Okay. Sorry. So the closely spaced doublets which arises from the fact that all electrons are spinning. and also the spin angular momentum PS. Previous one is the here angular momentum, that is you can see here orbital angular momentum L. S is the spin angular momentum, and here what do you say, magnetic quantum number ML is also there, and spin angular momentum, which is MS, is also there. There is a print mistake, PS. So what is the principal quantum number? Pauli's exclusion principle. So that here, what are the quantum numbers? N is a principal quantum number. The values is n equals to 1, 2, 2, 3. So which can determine the what is the size of the electron orbit, and also it arises from the quantization energy. Next, orbital quantum number. The value should be zeros to n minus 1, which can determine the shape of the electron orbit, and also which can arise from the quantization of magnitude of the orbital angular. Next, ML is the magnetic quantum number. MS is the spin quantum number. ML values are minus L2 plus L, and which can determine the orientation of the orbit in space arises from the quantization of the direction of the orbital angular momentum. Spin values plus or minus half MS values. So spin orientation up or down. Okay. So next. So what is the Pauli's exclusion principle here? No two electron can exist in an atom in the same electronic state. Okay. So you know pretty well what are the shells here, KLMN, and what are the subshells here, SPDF. Okay. So here for L equals to 0, 1, 2, 3, 4 like that, which are called the SPDF electrons respectively. So this is the case, and here you need to know that the subshells according to the exclusion principle, the values of L, there are 2 into 2L plus 1 possible values are there. How many possible values are there, which is to be discussing here? You need to know that what is n value, L, ML, MS, and how many number of electrons in subshell with spectroscopic rotation, and how many total number of electrons which can be occupied by a shell, which is to be denoting here. So you need to know that to 8, 18, 36, like that. The possible of the maximum number of electrons which can be occupied by shell formula is 2n square. You need to know that. Okay. So this is the case. Periodic table is also given here. Next, elements of quantitative theory. So in this elements of quantitative theory, let you know about the photoelectric effect and matter waves. What is photoelectric effect? When such intensity or frequency of light which is to be incidenting upon any alkali metals, the metal which is to be constituted the current, that current which is nothing but a photocurrent. Okay, so this entire process you can call it as a photoelectric effect. Okay, so here you need to know that here. So what is the basic concept according to the modern physics? So the light quanta, which is, you know that here photon, the energy is equals to h nu, which was proposed by the Max Planck in 1900. Okay, so which is concerning a heat radiation. And later on, Newton proposed the hypothesis of light as a corpuscular theory, and some of the properties which was successfully explained, and most of the theories are not explained by the Fresnel's based wave theory. Huygens he is proposed that and developed that. So whatever the failures which have been seen by the Newton's corpuscular theory, Huygens wave theory successfully explained. So this is about the particle nature of the light, which got the revised at the beginning of the century, and also he observed the new experimental observations. So you need to know about that So the photoelectric effect and also what is Compton effect, the interpretation which have been played a significant role to development the quantum theory. Next, de Broglie wave which is associated with the moving particle. If it is to be associated with the moving particle means a particle is a mass, okay, and also velocity. That means simply you have to say that momentum. So de Broglie associated with the moving particle where the wave travels with the same velocity of the particle. And what do you say? This is a wave velocity, which is known as a phase velocity. So here W equals to V lambda, nu lambda. Nu is the frequency and lambda is the wavelength. But you know pretty well according to the energy of the photon, nu equals to h lambda, E equals to h nu, or nu equals to E by h is the energy of the wave, h is the Planck's constant. And also mass energy relation according to the Einstein, E equals to mc square, where c is the velocity of light. So simply you can substitute in place of E, nu equals to mc square by h, and but W equals to nu lambda in place of nu mc square by h into lambda. And also using the de Broglie relation, lambda equals to h by mv, substitute there, and get cancelled, get cancelled. Okay, so remaining what is that here, which is to be showing that wave velocity and particle velocity are different, and particle velocity which is always less than that of the velocity of light, speed of light, and wave velocity w will be greater than that of the speed of light. So there should be a contradiction between the postulates of the theory of special theory of relativity. So you have to know about that concepts of wave velocity or phase velocity and also group velocity. So you need to know that what is the photoelectric effect. So the emission of electrons by the metallic plate or a surface alkali metals, which is when bombarded by a light, which is called photoelectric effect. So who proposed this? Heinrich Hertz in 1887. So you need to know about that. L is a light, S is a here slit, and there is a meter, battery, voltage is also there. So which is to be incidenting in a photovoltaic cell. So which is to be here emitting the electrons and which are to be moving towards the cathode to the anode. Then the plate which is to be constituted the current. That current is a photocurrent that is due to from the photoelectrons. What are photoelectrons? Where the electrons which are emitted by the metallic plate when the light is to be incident upon that. Okay. So what are the facts which you have to be observed for a given material? There is a minimum photo energy h nu naught, and here what are the characteristics of the material? And there is no photoelectrons which can be released by the radiation of frequency which is less than that of the threshold frequency nu naught. And what is the kinetic energy of the emitted photoelectrons? Okay, so that is a k maximum which depends upon the incident photon energy and the work function of a material. Next, photocurrent, which is directly proportional to the light intensity. If more light is there, more current is to be constituted. You need to know that. Then the photoelectric emission phenomenon, which is instantaneous. There is no time lag between the radiation and emission. Okay. So here you need to know that what is the Einstein explanation here. You know that according to the quantum theory, which was proposed by the Max Planck here. So the energy content of the electromagnetic wave, which is having the frequency nu, and the radiant source source can have only 0, h nu, 2 h nu, 3 h nu, like that up to the nh. So here we assume that the energy of the bundle, which you can call it as the quantum energy, which is related to the frequency, equals to h nu. So what is the work function here? You need to know that this is a photoelectric emission. I is inside, O is outside. S is a crystal. Okay. So what you have been chosen here? A solid material is to be chosen. So you need to know that here the emission, the photoelectric emission, which is far greater than that of the EF plus W. W is a work function, EF is a Fermi energy. Okay. So here K value, that is a kinetic energy value, that is 3.2. By solving the 3.3, you are getting basic formulas of m square equals to h minus w. This is called here Einstein photoelectric equation. So how it is to be changing here with respect to the frequency. More frequency, kinetic energy is more. Okay, gradually increases. That is the case. Next, what is Compton effect? Here, A.H. Compton in 1923, they have been discovered that when a beam of X-rays, okay, well-defined wavelength lambda naught, which is scattered by a metal foil, that means it is to be incidenting. There should be a scattering is going to take place. Scattering means the light is spreading in all directions, okay, which should take by the metal foil, and the scattering radiation at angle theta, incident radiation, which was found to contain the component of the well-defined wavelength lambda naught, which is longer than that of the lambda. So this is called the Compton effect. So experimentally, X-rays for the X-ray tube T is a target here. Okay. So these are the X-rays which is to be emitting. There should be a crystal is there, incidenting, scattering in all directions. Okay. So here X-rays from the X-ray tube capital T, which is to be striking a graphite block, where the scattering is to be takes place in all directions. So that what is the target of the X-rays tube was molybdenum. Okay, what do you say? Molybdenum. So what is the K wavelength is molybdenum? 0.708 angstroms. So here the monochromatic radiation which was employed in this category. So in this, what is the P means primary time, S is secondary line, theta is the scattering angle, B is the Bragg's spectrometer. Okay. So where the angle is to be changing here when theta equals to 0, sharp, 45 degrees, lambda naught and lambda theta. Okay. And also theta 90 degrees, two peaks is to be observed. When theta is more than that, 135 degrees, there is a two different peaks. A large depth is to be observed. There is a difference. Okay. That means there is a shifting is to be observed. So what is delta naught? Delta theta minus delta. So which can represent the shift in the wavelength of incident X-rays. So which can result the scattering, which was found to increase the theta and is independent lambda naught, and as the nature of the scattering. By doing this, before the scattering, after the scattering, what is the according to the elastic collisions? Okay, so you need to follow that conservation of energy of uh, to the collisions here. H nu naught equals to h nu theta plus half n square. Similarly, by applying the E equals to mc square formula, rest mass and mass of the block here. So simplifying, you will get the equation. So you need to only, the thing is that you need to do the practice. So more and more. So you have to calculate that. What is the wavelength shift delta theta, lambda theta, which is nothing but h by m naught c. H is the Planck's constant, m naught is the rest mass, c is the speed of light, into 1 minus cos theta. Okay. So this you need to know that. There should be a problematic questions is also going to be asked. Next, what is the dual nature of the light? Okay. So from starting onwards, we have to be saying that. So Newton corpuscular theory and also Huygens wave theory. And so sometimes the light behave like a wave, and the other time it is behave like a particle. Okay. So that is related to the dual nature. And here Young experiment is also going to be showing that here how the interference is to be takes place. Corpuscular theory, wave theory, Young's experiment. Okay. So in some of the experiments, the electron, which is to be considered as a particle, and the other experiment, electron may be considered as a wave. Okay. So that means a classical theory and as well as the quantum theory. Classically, we are speaking, and also quantum theory is also going to be speaking that here. Not only particle, waves. So X-rays, ultraviolet. Okay. So here, which is having such a frequency or a wavelength here. So interacting with the matter, there should be some effects which is to be takes place. Just now we discussed that Compton effect. There also we are to be talking about the waves here. Lambda shift in the wavelengths here. So that is entirely related to the dual nature of the light. Okay, quantum theory of radiation. And next, concept of matter waves. Yeah, here also you need to do the mathematical calculation. That means when the radiation displays in the characteristics of particle, that is nothing but a matter here. Sometimes display the characteristics of waves like a particle and wave dual nature. So like that, photon energy equals to h, and also mass energy relation equals to mc square. So that's it. We have to do that. You have to derive that. Next is the Davison and Germer experiment. So here the in 1927, Davison and Germer, they have been performed the experiment using the beam of electrons instead of X-rays. Okay. So here, this is the filament. So there should be a battery. The tungsten filament which is to be heated electrically when the battery is connected. The emitted electrons which are to be accelerated by applying such a filament and play. So the electrons emerge from the kinetic energy, electron volt EV, which is in the form of fine parallel pencil, just like an electron gun. Okay, which the beam travels in free space and falls normally on the crystal, single crystal of nickel at C. So that which is enclosed by vacuum chamber. Then the reflected electrons are collected by the detector D, which is nothing but a Faraday cylinder. And again, this cylinder surrounded by another cylinder, which is to apply a retard potential. So this is a fine beam, just like a pencil through pencil, emitting on the crystal C. Okay. So there should be a detector which is to be detecting here. A reflected beam is there. IV beam. You need to say that the relation between the color current and the angle is changes here. And also one more thing here, de Broglie equation is also to be used. Bragg's formula, that is a 2D scientific equals to n lambda. Okay, so there you have to experimentally and by theoretically what is the wavelength value which is to be given out. You are to be correlating next relation between different velocities, group velocity and particle velocity. That mu g w is the velocity, then the velocity group velocity. So g equals to w minus lambda dw by d lambda, and for free space is 0, then g equals to w. And here by doing that calculation part and reducing that, how the equation which is to be relating and how you are going to be using the de Broglie relation lambda equals to h by v mb in the previous equation. You have to reduce the equation. What is the relation between them? You can easily get it. Later on, group velocity and phase velocity. Same thing is to be taken here. Only the thing is that here wave velocity as well as the de Broglie sphere equals to h nu is also to be considered. We have to consider w equals to g by 2. G is the group velocity. Okay. So the wave velocity or the phase velocity, which is a half of the group velocity. So uncertainty principle. Tomorrow we'll discuss.